All right, hopefully that this is not hard for you. We're going to go label the spine. Mu is equal to 42. My sigma is equal to 7. I'm going to go one standard deviation in both ways, so I get 49 and 36. 2 in both ways. 7 is 56, is that right? And subtract 7 here, that's going to be 29. And then 3 standard deviations. Subtract, I get 22. And I get 63. We need to talk about 68%. 95%, that is a 95. And 99.7%. And then here we're going to be talking about a lifespan of copiers. Okay, copy machines, okay? Don't forget the title. Okay, now it says here, a company will, with several large office buildings, buys 200 of these copiers. The salesman tells the boss that 190 of them, 95% of your copies were last. Okay, so 95 is 2 standard deviations. 29 and 56. Okay, so comment on this, that this is just a prediction, just an estimate. Okay, the third quartile. Well, where does the third quartile happen? All right, and so hopefully you remember that the third quartile happens at 75%. And we need to know, so go look in your Z-score chart and let's look up 75%. Okay, and so I'm going to work backwards on that. So 75% is this much, right? Mu equals, I don't have enough room to do all of this. And so the probability that months is less than x is equal to 0.75. X is equal to, and so z is equal to x minus 42 divided by 7 is equal to. Okay, so let's go find out what my z-score is. Okay, so I get 0.67, and so now I'm going to use Algebra 1 to solve for x. And I get 46.69 months. Okay. What percent of the copiers are expected to fail before 36 months? Okay, so if we look at 36, here's 36. So I got the probability of months is less than 36 is equal to, so I get z is equal to 36 minus 42 divided by 7. I get negative 0.86. So now let's go look on the z-score chart and see what that is. I get 0.1949, so it's going to be 19.49%. Okay, so we still want 36 months. Come on, Schwartz, let's draw this. I want mu is still equal to 42. This time, my standard deviation is my x. Still have 36. Still have the shading, and it's 10%. So I'm going to look up my z-score for 10%. And I get negative 1.2 36 minus 42 divided by my standard deviation is equal to negative 1.27. Okay, so 36. So what do I get? Negative 6 is equal to negative 1.27 sigma. Divide both sides. So I get sigma is equal to 4.72. And that is months. Okay. Okay, explain what that means. Okay, now before it was 7, now it is 4. So that means that we would have to be more consistent, more stable, right? We need to be more stable, more consistent, because my spread is getting smaller. Okay, now a competing manufacturer says that only 90% of their company's copiers will last at least 36 months, 65% at least 42 months. What normal parameters is that the manufacturer is claiming? All right, so the deal is here, do you see that we have two variables, mean and standard deviation? When we have two variables, we need two equations. Okay, so we need to look up 90. Well, 90 is going to be 1.27 because if negative 10 is negative 1.27. 90 is going to be 1.27. And now let me look up 65, okay? Okay, so look what I wrote down here, that I have two equations. I'm going to get another color. And this right here is for the 36, because remember we need to find my mean and my standard deviation. And this is for the 65% for 42 months. Again, I need to have my mean and standard deviation. So I need to come up with a linear equation. So I get 36 minus mu is equal to 1.27 sigma. And here I get 42 minus mu is equal to 0.39 sigma. All right, and so now I'm going to write both my mu and my sigma on the same side. So I get 36 is equal to mu plus 1.27 sigma. And here I'm going to get 42 is equal to mu plus 0.39 sigma. All right, do you see that this is a matrix problem? So I'm going to go to my calculator and put it in as a matrix. All right, so I put it into my matrix, and I get mu is 44.66, 44.66 months. And I get standard deviation is a negative number. Hopefully you realize that standard deviation can never be negative. So I get 6.82. Now, I know I'm going to be doing this problem. I do this problem every year before the test, all right? Called Algebra 1, you guys. All right, good luck.